Welcome again to Shifting Grades. We are still under the topic SURDS, which we have already started. Before we continue, kindly subscribe to Shifting Grades and share the link with your friends so that they may be getting also our updates whenever we do a lesson in the YouTube. We have started to deal with rationalizing the denominator, and for simple fractions which are surd in nature, we have seen that you just multiply with the denominator in both the numerator and the denominator itself, such that you've not affected the value of the number. For example, when we add 1 over root 7, we said you multiply with root 7 in both cases, such that mathematically the value of this original expression is not affected. And this was giving us root 7 all over root 49. And because root 49 is rational, then we have it as 7, like that. Now, before we go for a further case where the denominator is binomial in nature, I would like us to first quote this, that when a surd expression is binomial in nature, binomial means it is having two terms. Then we open or we expand it normally, or just like the usual binomial expressions. Let me give an example. If you are told, for example, to evaluate then you're given root 3 minus root 5, then into root 10 plus root 2. You are told evaluate. For these cases, you just expand normally, the way we expanded quadratic expressions in book 2, which has two factors like this. You just begin with root 3, then you multiply root 3 with everything. In this term, root 10 plus root 2, then minus root 5, again with everything, root 10 plus root 2, like that. Therefore, this becomes root 30 plus root 3 by root 2, root 6, minus root 50, then negative root 5 by root 2 becomes negative root 10, like that. We can now simplify further. We cannot add this and this, and we cannot not subtract, because we are saying even if they are both in root or in they are root 2 both, or this they are the square root, so the order is the same, but under the sign we have different numbers. Therefore we cannot add, neither can we subtract. Therefore we can proceed to call this one root 30. It is in the simplest form because there is no perfect root under that. There is no 9, there is no 16, therefore it is in the simplest form, plus root 6, which is also simplified, then minus, in 50 we have 25 by 2, like that, minus root 10, which is fully simplified. Therefore with that we can have this one as root 30, plus root 6 minus the square root of 25 is known, but for 2 isn't. Therefore, square root of 25 is 5, but square root of 2 is unknown, minus the square root of 10. Therefore, that's how we expand a binomial expression, which are SURDS, just normally. One term by everything in the other factor, and the other term by everything in this other factor. Just like that. So with that concept now, after reviewing it, I would like us now to go to rationalizing the denominator, or simplifying by rationalizing the denominator, where the denominator is in binomial form. Consider, let's consider something here. When we are told to multiply 5 minus 2 root 7 times 5 plus 2 root 7, like that. Let's try to open this. The way we have said, it is 5 into 5 plus 2 root 7, then minus 2 root 7 into 5 plus 2 root 7. 5 with everything, and negative 2 root 7, that is, with everything again. Therefore, this becomes a 25 plus 10 root 7 minus 10 root 7 minus again. This is 4 root 49. When you multiply 2 by 2, and under the roots of 7 by 7, like that. Therefore, this becomes a 25 plus 10 root 7 minus 10 root 7 simplifies. It becomes a 0 because it's a common term. 4 root 49. This is 25 minus 4. Root of 49 is known. It's 7. Therefore, this becomes 25 minus 28. This becomes negative 3. Like that. Therefore, we can see now, when we multiply a term which is in this form, 5 and 2 root 7, with a negative and again with a minus here, we are finding that the answer is a rational number. We can also consider this. We can also consider this expression. Let's consider another one before we conclude. Root 3 minus root 2 multiplied by root 3 plus root 2. Like that. Again, we start by root 3 by everything here. Root 3 plus root 2, like that. Then negative root 2 with everything here. Like that. Therefore, opening this gives us root 9 plus root 6 minus root 6, then minus root 4. Therefore, this is, root 9 is a rational number. It gives us a 3 plus this one and this one, they cancel out. Root 6 minus root 6, it becomes a 0. Minus root 4 is a rational number. It gives us 2. The answer is 1. Therefore, in these cases now, we have seen that when two expressions are such that they are just the same terms, but in one there is a minus and in the other one we have a plus, then they simplify to give us a rational number. In both cases, we're getting a rational number. Therefore, we cannot the following. We cannot NB each of the above the ones we've covered just here, expressions, each of the above expressions reduces to a rational number. reduce to a rational number like that. Then we can say if the product of two binomial SURDS gives a rational number, then the two expressions are said to be conjugates. Let me write it in full. They are said to be conjugates. They are conjugate of one another. That is, if you have root A minus root B and root A with a plus now, root B, we say they are conjugates. They are called conjugates. Therefore, now we can say, to simplify a third fraction, we multiply with the conjugates. Of the denominator. In the numerator and the denominator. Therefore, the two cases now, you find that for you to simplify a SURD which is binomial in nature in the denominator, then you multiply both the denominator and the numerator by the conjugate of the denominator, because by such doing, the denominator will become a rational number. Let me give an example concerning the same. When you are told simplify the following, when you are told to simplify then you are given 6 all over 3 minus root 3, like that. You are told to simplify this one. Solution. We have the denominator is 3 minus root 3, like that. Therefore, the conjugate of 3 minus is 3, now with a plus, like that. Therefore, it is now this conjugate which is going to multiply both the numerator and the denominator. Therefore, now we multiply 6 all over 3 minus root 3. So in both cases, we multiply with the conjugate of this. The conjugate is 3 plus root 3. Then we multiply in both cases such that the value of this expression is not affected, because this conjugate is in both cases and it can simplify to a 1. Therefore, the value of this expression isn't affected in any way. Therefore, now multiplying this, we will have 6 across everything. We will have 18 plus 6 root 3. Then all over 3 by 3 plus root 3. Then negative root 3, again with everything, like that. Therefore, this becomes 18 plus 6 root 3 all over, this is 9 plus 3 root 3 minus 3 root 3 minus root 9, like that. Therefore, with that now, we can say this is 18 plus 6 root 3 all over plus 3 root 3 minus 3 root 3 simplifies to a 0. Then we will have 9 minus. Square root of 9 is a rational number and can give us 3. Therefore, this gives us now 18 plus 6 root 3 all over 6. You can see now we have made the denominator a rational number. Then now this is not the simplest form. We are told to simplify. Therefore, we make it simple by checking whether there is a common factor, and in the denominator, in the numerator, we can see that there is 6 in both cases. Therefore, factoring out 6 will remain with 3 plus root 3 all over 6. Therefore, 6 and 6 cancels out, and the answer to this becomes 3 plus root 3, like that. Therefore, that's how we handle a question which involves simplification and the denominator as a binomial third form. That's how we handle it. I'd like to give another example before I conclude with another concept under the same topic. When you're taught, simplify, leaving your answer in third form. Simplify, leaving your answer in third form. Leaving your answer in third form. And we are simplifying this expression, which is 2 all over root 6 plus root 3, then minus 5 all over root 7 minus root 5. Like that. We are told to simplify. Then the answer, we are leaving it in third form. What I encourage students to do is that when you get this one, and you're finding that this is not conjugate with this one, such a question, treat it as a normal fraction. Therefore, to simplify this one, use the LCM method. The LCM method of solving fraction in book 1 mathematics. Follow it. And therefore, in these two fractions, the LCM is root 6 plus root 3 multiplied by root 7 minus root 5. That is the LCM. Therefore, what you do is LCM divide by this term here, we get 7. We get root 7 minus 5. Therefore, now it is 2 times, when you divide LCM by this term, we remain with root 7 minus root 5. Like that. Minus, this is 5 times LCM divide by root 7 minus root 5. We remain with root 6 plus root 3. Write it well. Like that. Therefore, now you can open now in both cases. This should be 2 root 7 minus 2 root 5 minus 5 root 6 minus 5 root 3. Like that. Divide by. We can now again open this one and we will have root 6 root 7 minus root 5. Then plus root 3, root 7 again minus root 5, like that. Therefore, here, there are no like terms, and therefore, the numerator is already in its simplest form. Therefore, we just copy it the way it is. root 6 minus 5 root 3. Then you divide by, this one will open to root 42 minus root 30 plus root 21 minus root 15 when you multiply through. Under this, you find there is no common term again, and the surds are also in simplest form. Therefore, we cannot simplify this expression further because we don't have a perfect root here. There is no perfect root here. There is no perfect root here, and also in this case. Therefore, you find now the expression as simplified in surd form. So that's how we leave our answer for that case. That's how we leave it for that case. Let me give a similar example, just one. Then we finish up. Just one example on that. Then we finish up. You are told simplify by rationalizing the denominator. Simplify by rationalizing the denominator. Then we have root 5 all over 3 root 15 minus 2 root 10. Like that. Simplify by rationalizing the denominator. Therefore, we will take our root 5, divide by 3 root 15 minus 2 root 10. Then we multiply with the conjugate of this one. And the conjugate of this one is when we take 3 root 15, then now a plus instead of this minus 2 root 10, like that. And now, to avoid affecting the value of this, we multiply also the conjugate in the upper side or in the numerator side. Like that. Therefore, now we can multiply this 3 root when we have 15 by 5, 75, yes, plus 2 root 50, like that, all divided by, we now open this one now. 3 root 15 times 3 root 15, or we can just go stepwise, plus 2 root 10, then now negative 2 root 10, with again everything, like that, so that you may expand step by step. In the numerator, we can check that 75, there is 25 by 3. Therefore, this will be 3 into 25 times 3 plus 2 into 25 by 2. Like that. Then all this we divide by 3 root 15 by 3 root 15. We will get 9 into root 15 by 15 to 25 plus 6 root 150 minus 2, no, this is a 6, then 10 by 15, 150, like that, yes. Then now 2 by 2 it becomes negative 4, then 10 by 10 becomes root 100. Therefore, with this now, this one is a rational number. Therefore, the square root of 25 is 5. Therefore, 5 by 3 becomes 15 root 3 plus, again, root of 25 is 5 by 2, 10 root 2 is unknown. We divide by 9 root 2, 25. Root 2, 25 is 15. Therefore, 9 by 15 becomes 135. Then root 6 root 150 and negative 6 root 150, they cancel to a 0. Therefore, we remain with now minus 4 times 10, which is the root of 100, gives us a 40. Therefore, when we subtract a 40 here, we are having 95. Therefore, it will be 15 root 3 plus 10 root 2 all over 95. We can factorize further by taking out 5. I think 5 is common in all cases. Taking out 5 from the numerator, we shall have 5, then 3 root 3 plus 2 root 2 all over 95. So 95 divided by 5 gives us 19. Therefore, this becomes 3 plus 2 root 2 all over 19. Therefore, it is good to finalize and give the answer in the most simplified form, like that. Therefore, that's how we rationalize the denominator and simplify a SURD. I would like now to show some application of SURDS in trigonometry. Now, trigonometry is trigonometry 1, which is a book 2 concept. We have trigonometry and SURDS. Trigonometry and SURDS, I will just show how they are related, and I leave you with an assignment of operating a few examples on the same. Here, you'll find that, let me give a question. We'll approach it using a formed question. For example, you are told to express in SURD form and simplify. Express in SURD form. And then you simplify as usual. Therefore, what happens here, I will show you how to express in SURD form, then simplifying, we have seen it by rationalizing the denominator. So the question can be 2 divided by 1 minus cosine of 45 degrees. B, another question can be root 10 all over 1 minus the tangent of 60 degrees. Another question can be 1 plus cos 30 degrees all over 1 minus sine 60 degrees. Therefore, this is how we operate them. Solution. In this case, we should know that from the math table and from the calculator, we cannot have these trigonometry ratios expressed as SURDS. And therefore, what we do, we take an equilateral triangle like this, which is a unit triangle, which is equilateral, a unit triangle which is equilateral, meaning each angle is 60 degrees, 60 degrees and 60 degrees. Therefore, what we do is a unit circle, meaning a unit triangle, meaning each side is a unit, just one unit. Therefore, what we do, we bisect this angle, automatically bisecting this side, meaning now this angle has become 30 and this side has become half. And therefore, with that now, we can extract the trigonometric ratios for the special angles 60, 30, and 45. Therefore, we have this one has become a 90, and after subdividing this became 30, this remains 60, the way it was. So this is a 1, and this has become a half because we have bisected here. Therefore, we are considering now one of the halves after bisecting. Therefore, considering this half, we can get this side. And this side will be 1 squared minus a half squared. Pythagoras theorem. This will be 1 minus a quarter, which will be 3 quarters. Therefore, the size of this side is now the square root of 3 quarters. And when we get square root of 3 quarters, you find root 3 is unknown, but the square root of 4 is known. It is a 2. Therefore, the size of this side is root 3 over 2. With that now, because we have 30 and 60, and this is a right-angled triangle, then we can get sine 30 as the sine of an angle is the opposite, which is half, divided by the hypotenuse, which is 1. Cosine of 30 will be, the cosine of an angle is the adjacent side, which is root 3 all over 2, divided by the hypotenuse, which is 1 in this case. Therefore, the cosine of 30 becomes this. Then tan 30 is, when we have that here, tangent of an angle is opposite divided by adjacent. Therefore, the opposite is a half divided by this one, meaning multiplying by the reciprocal. And this will be 1 all over root 3. Like that, because the 2 cancels. Like that. For 60, we can also extract